Give me 1 second, George. Hey, I tell you what. Are you okay? There's a guy's at the door. I need to talk to you for just a second. So can I put you pause this for a second? Are you okay hanging on for a little bit?
Yeah, that's totally fine.
Okay, I'll be back here in a few minutes.
Okay.
Okay, George. Yeah. So I'm back.
Okay.
So it's real simple. If you want to know where vertical asymptotes are, here's the recipe. If you find the zeros of the denominator, so all the places, all the values of x that are going to make the bottom 0, and you find the zeros of the numerator, okay? Any place where you have zeros of the denominator that are not zeros of the numerator, so values of x that make the bottom 0 but not the top 0, those are places where you're going to have vertical asymptotes.
Okay.
Okay. Does that all make sense, George?
Yeah. I don't know. Have you been talking for the past minute?
Oh,
Okay, good.
Yeah.
Sorry. I didn't know because I couldn't hear anything, so I wasn't sure.
Oh yeah, no, I was seeing. I thought maybe you were doing a problem or you had a question.
No, sorry. Not bad.
Yeah, that's it. So what you would do, like you can see my screen now.
Yeah.
So like for this problem here, you're gonna find. Let's see if I just let this play here.
Yeah.
Well, what happened to? I don't get why that's. Oh, I think I skipped.
Want to know where are the x-intercepts? What's the end behavior of the function? In between all the x-intercepts. There's one other little thing we have to deal with here. For a polynomial, what's the domain?
Oh, okay, I see.
No, we've already dealt with this a little bit.
So see what we're doing here is we're just factoring the top and the bottom, right? So on the top we can factor out a -4.
So then
the bottom breaks up into x minus 5 times x plus 2, right?
Right.
So the zeros of the bottom are 5 and -2. Agreed?
Yeah.
Okay. So those are going to be the places. 5 and -2 are the places where the bottom is 0. And so those are places where the function doesn't exist, right? You can't divide by 0. Okay. But they're different. At 5, you have a 0 of both the top and the bottom. And so that's a place where it's just going to be a hole in the function. It's not going to be a vertical asymptote. There's just going to be one little pixel missing in the graph. But at -2, that's different. At -2, that's a place where the bottom is 0, but the top is not 0. So if I were to plug in -2, I would get some number on the top, and on the bottom, I would get 0. Well, a number divided by 0 is infinity. That explodes. So that's a vertical asymptote.
Right. Okay.
You see what I'm saying?
Yeah.
Okay.
So
and if you want to look, I mean, like I said, if you want to look at some really detailed examples, I've got a like more than an hour of examples on that Google document.
Okay.
Yeah.
So I have another question because I just started the review for
Sure.
For what's it called?
The final test.
Yeah.
Yeah.
So the question that I'm doing here is, it says the intensity of a sound varies inversely with the square of its distance from the source.
Right.
At a distance of 1 meter, the intensity of a jet engine noise is 10 watts per square meter. An airport cargo worker is 15 meters from the jet engine. What is the sound intensity at this distance?
Okay. Yeah. So here's what they're getting at there. So you can see my document camera?
Yeah.
Okay. So repeat that then. It says.
So the intensity of a sound varies inversely with the square of its distance from the source.
Okay, so that's saying that y is proportional to 1 over x squared. Okay, but what we'd rather do is we'd rather write that as an equation.
Okay.
So we write that as y equals some constant times 1 over x squared, which is the same thing as saying a constant divided by x squared. Okay, so that's my equation. Okay.
Okay.
So in this case, what does that mean? So y equals intensity, because that's the output, and x equals distance.
Yeah.
Okay. So then, what else did it say?
So at a distance of 1 meter, the intensity of a jet engine noise is 10 watts per square meter.
Okay, so when x is 1, y is 10, right?
Yeah.
Okay, so then that means we can use that to solve for k, which is what we call the constant of proportionality.
Right.
Okay. So if I plug in 1 for x and 10 for y, I get 10 equals k over 1 squared, which just means that k equals 10, right? So then we can change our equation now. Now that we know what k is, our equation is y equals 10 over x squared. So now we can use that equation to find any output we want when we enter an input. So what's the next part of the question asked?
So an airport cargo worker is 15 meters from the jet engine. What is the sound intensity at that distance?
Okay, so when x equals 15, y equals what? Well, we just plug 15 in and find out.
Okay.
Okay.
So then.
So we get 10 over 225, which is going to be 2 over 49. And they probably want a decimal from that, I'm assuming. But
yeah, it says round to the nearest thousand.
Yeah, so then there's your answer. They just want whatever that is a decimal.
Yeah, okay. So I just did the math. I think it's 0.04 repeated.
Yeah.
Pretty much.
That's it. Yep. Mm-hmm.
Okay. I just was unsure I forgot how to do that kind of because it's been a while, a little bit.
Oh, sure. No, that's no problem.
Yeah, so I just wanted to ask. Okay.
Yeah, that works.
Yep. Or no, that's all.
Oh, no other questions?
No, yeah, that's all. That's
okay.
Really I had questions on.
All right, good. Well, hey, check out, like I say, check out that Google Doc if you need more. You need some more depth on the rational function stuff. Graphing them. You may not. You may not even need to do it, but if you do, it's there.
Yeah. I just I was unsure because the beginning, the beginning of the unit, I was a little unsure if I fully understood how to do it. So yeah.
Yeah. Okay. Good stuff. All right. Hey, good work, George.
Thanks.
You betcha.
Yeah. So I'll see you later, Mr. Way.
Okay. Sounds good. Have a good day.
Yep. You too. Bye.
Okay. Bye.